Right, so in this video, we're going to continue to talk about exponents. And in your class, you're going to be dealing with variables this year. So we're going to talk about how you handle a variable when you're dealing with exponents. So we're going to start with raising a variable to a power. Okay, so we're going to start off with the example x to the 6th power. So remember that x is now a base. It's a variable. We don't have a number for x, but it is the base of our problem. And 6 is the exponent. So if we just follow the rules, this is an exponential form. If you remember that math term, you need to know this is exponential form. If you follow the rules for exponents, and I say, hey, can you tell me this in factored form? Then you would just follow what you would do as if x were just a number. You could pretend it's 5, you could pretend it's 10, you could pretend it's 2. If it was 2, we would write 2 times 2 times 2 times 2 times 2 times 2. But it's not, it's x. So we're going to write x, and I'm going to use a dot for multiplication, very popular in our algebra world. X times x times x times x times x times x, and I have 6 factors of x. So I put this from exponential form into factored form. Expanded form is another way they call that. Now, so the 3 forms we studied were exponential form, factored form, and then standard form. In this problem, we cannot put this answer into standard form because we don't know what number we're using here. If I told you that x was 2, you could replace all of these x's with 2's. You would substitute that in, and then you could put it into standard form by multiplying the problem out. But since we don't know what x is, I'm going to zap those two. This is as far as we can get. 2 forms, exponential form and factored form. All right, so in this next problem, we have a factored form with a variable. So this is saying you whatever y is, we're going to repeatedly multiply it to itself 10 times because there's 10 y's. So if this was 5, we would go 5 times 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 5. So you would repeat 5 10 times. Because the variable is the same, our number for it also has to match all the way across. So this is in factored form. And so if you could put it into exponential form, y to the 10th power. But in these forms, you couldn't convert it to standard form because you have no idea what y is. Until we give you y, you have to just leave it in either factored form or exponential form. If I told you what y is, you would put that number in 10 times, and then you would multiply it out. You could get standard form. But as a variable, this is what we know. This is as far as we can get. So I would like you to try 2 examples. Example 1, do first. And that is to write this right here in exponential form. I'm sorry, not exponential form. Write that in factored form. And then turn the video back on to see if you got it. Okay, so a to the 7th power is a times a times a times a times a times a times a. 7 a's multiplied to itself. Notice I am using dots between my variables. The reason we do that is if we use x's, it would look like this. And in the algebra world, an x could look like a variable or a multiplication symbol. So it gets very confusing if we're saying a times a, or if we're saying a times x times a times x. So in the algebra world, we avoid using the x in our multiplication problems, and we replace them with different notation. And one of those notations is a dot. And you'll learn other ways to write that multiplication with algebra throughout the year. Okay, example 2. I would like you to write this in exponential form. You ready? How about we do b times b times b. Write that in exponential form. Pause the video, turn it back on to see how you did. So the number that is being repeatedly multiplied is, we call that number b, the variable b. Represents some number, and that's our base. It's repeating itself with multiplication, and there are 3 factors. So it's b to the 3rd power, or b cubed. Remember, that has a special name, a nickname. We could say b cubed. So you should have all of this on your paper, and neat and organized as it appears on the screen. And now we're ready for the next piece. We have special powers or exponents that we need to talk about. And the first one is when the exponent is a 1. Your answer, whenever your exponent is a 1, is just the base that you start with. So, if we have 4 raised to the 1st power, your exponent is a 1, your answer is just the base 4. So we have 1 factor of 4, so that's our answer. Pretty simple. So if I have 37 to the 1st power, the answer is the base, 37. I have 1 factor of 37, done. 1 and done. All right, so we're going to take a look at x to the 1st power. When we have a variable in a problem, this number we can read as any number we plug in. A variable is given to you so that you can replace it with any number. It varies, it changes. So any number we put in there, any number raised to the 1st power. That's how we read that. Any number raised to the 1st power. So let's just say that I tell you what that number is. It's 2. That would be 2 to the 1st power. Our answer would be 2. If I say it's 5, 5 to the 1st power, our answer would be 5. We don't know what that number is, but we do know that if you raise it to the 1st power, you get that number back. So any number raised to the 1st power is that base back. So that's a general rule. Any number to the raised to the 1st power is itself. So when you see these problems, they're so easy. You just have to rewrite the base. Our next special case is when the exponent is 0. The answer is almost always 1. The exception is when the base is 0. We say this is undefined. Doesn't exist. There's no answer to this. So example, here's what I'm talking about. If we have 0 raised to the 0 power, the base and the exponent are both 0, then it's not 1 like it says. It's not equal to 1. It's undefined. It actually doesn't exist. So you just have to memorize that fact. If you have nothing and you raise it to the nothing power, you have an undefined situation. Other than that, anytime you see an exponent that's a 0, you know the answer is going to be 1. Now, I'm just going to have you memorize this fact. Memorize that any number to the 0 power, the answer is 1. Because you will, in your next math course, pre-algebra, you will be discussing why that happens. It will make a lot of sense to you when you go through what we call the rules or the laws of exponents. It will become much more clear as to why this special case exists. But for right now, we're just going to have you memorize the fact. So 8 to the 0 power is 1. Any number to the 0 power is 1, so 8 to the 0 power is 1. 527 to the 0 power is also 1. And here is our general rule again. Let's read this with the variable in mind. Any number, that's what y stands for. It can vary. We can put any number in there, raised to the 0 power is 1. That's our general rule. Except zero. 0 is the only number when you put it in here, you get an undefined situation. Any number raised to the 0 power equals 1. So go ahead and memorize that fact, put it to your memory, and those will be very easy problems for you if you can get that memorized. Now we're going to review powers with special names, and we're going to start with a square. So the name of this figure below, it's a square. We know that because when we look at the lengths of the width and the length of the square, they match. They're the same. So we're going to look at the area of this square. To find the area of a square, you take the length, L, times the width, W. In this case, since they're the same, a lot of times in our math classes, we will call this S for a side length and this S for the side length. Same variable. Instead of using two different variables, we say it's S times S, because we know that these numbers match because it's a square. So that means with what we just discussed with our variables, we can write this as S to the second power. So to find the area of a square, rather than using L and W, we replace it with S to the second power. We apply our knowledge of exponents, and we specialize this formula for squares only when you're finding area. So if we want to find the area of this square, we're going to go A equals, we're going to plug 4 in for S, 4 to the second power, and that's 16, and we're going to remember our unit, 16 inches squared. The 2 comes after your units to indicate that we found area, inches squared. All right, so square is one of those special powers. We could say that this is 4 to the second power or 4 squared. Now, what is the name of the figure below? This is called a cube. We know it's a cube because the length, the width, and the height are all exactly the same. We know that this is a rectangular prism also, and to find the volume of a rectangular prism, we take the length times the width times the height. But since they're all the same, then we will call this, instead of L, W, and H, we will call it S. So its volume equals S times S times S. And we also know with our experience now with exponents that this is the long way to write S to the third power. And the nickname for that third power is cubed, because it's a cube. S cubed tells us the length, the width, the height, and are all the same. So then when we go to find the volume, we're simply going to go 5 to the third power, which when you multiply that out, you get 125 centimeters cubed. So those are our 2 powers with special names, square and cube. All right, the final piece is critical thinking. Can you apply what you know to these examples? We are going to write equivalent expressions. So when I ask you to do this, I want you to think about the different numbers you can use as a base for the given number in standard form. Then write out longhand multiplication first. So the number of focus here is going to be 81. It's in standard form. Can we write that with a base of 81 and an exponent? Can we write these equivalent expressions for 81 in exponential form? So if you think about it, if you want to get 81 in standard form, you have 81. What power would have to go here so that when you worked it out, you got 81? The answer is 1. So 81 of the first power is 81. That one was pretty basic. It's another way to write 81 in exponential form. But what if I change the base? We start with 81, but I change the base to 9. So what we're saying is, how many 9s will it take till I equal 81 when I multiply them together? So I start off just writing out the longhand. What's 9 times 9? Well, it's 81. I'm done. I found it. It takes 2 9s multiplied together to give you 81. So we're going to write a third way to write 81 in exponential form. And the third way is using a base 3. So how many 3s will it take to multiply together to get 81? Well, let's just start writing some out. Well, 3 times 3 is 9. So we're not there yet. We've got to get to 81. Well, 9 times 3 is 27. We're getting up there, but we're not to 81 yet, so we need another 3. We're just repeatedly tacking on another 3. 27 times 3 is 81. We found it. So how many 3s did it take to multiply together to get 81? It took 4 of them. So we would say 3 raised to the 4th power is an equivalent expression for 81. This is an exponential form. 81 is in standard form. But they are equal even though they look like very different numbers. So critical thinking, can you go back and forth? Can you figure out a base with an exponent to get a number given in standard form? Just kind of applying what you've learned and making you think deeper. All right, that's all we got. Have a good day.